Hi, my name is Vicky Ramsey and I've been studying physics since 2006. This is episode 7 of my E&A video series. In episodes 1 through 6, I talk about the mechanics regarding the engineering of atomic clocks with regards to energy considerations, and the possibility of a potential deviation from Einstein's theory of general relativity via the principle of mass-energy equivalence. I outline how, on the basis of this potential deviation, my introduction of 6 operations of modification in the form of axioms does not change the general relativity equations, but that this modification does, however, change the outlook on the cosmological model, which necessitates a rethink of the physical consequences regarding the redshift distance correlation, where I then introduce my proposal for a reinterpretation of the cosmological redshift observations, and I talk about how this reinterpretation results in cause and effect mechanics for the observed Hubble tension, where the Hubble tension then could be viewed as empirical evidence in support of a contracting universe. I go on to describe my proposal for a cyclic contracting bounce cosmology in relation to the peculiar velocity observations of the galactic flow regarding the galactic supercluster Laniakea with respect to the phenomenon dubbed as the Great Attractor. And then I explain how dark energy, entropy, and the arrow of time can be described within this proposed novel cyclic contracting bounce cosmology. I want to talk here about the fact that this modification of general relativity is falsifiable via a novel atomic clock comparison experiment. So, to give a bit of background, the falsification principle proposed by Karl Popper suggests that for a theory to be considered scientific, it must be able to be tested and conceivably proven false. However, although physical theories that provide a means by which to test the proposed hypothesis are common, it is far more rare that a person propose a theory that can be outright falsified by its suggested experiment. In fact, if you Google the term scientific falsifiability, you will find that there is much controversy. There are those who will try to say that falsifiability in science is a myth, and the arguments both for and against the principle of falsifiability become complex and long-winded, to say the least. Where, to say so, I personally don't have much energy for that sort of thing. What I do know for a fact is that with regards to my modification of general relativity, the experiment that I suggest to test this modification will either outright falsify my modification, or it will outright falsify a small but vitally important aspect of the current interpretation of Einstein's general relativity. What I wish to discuss here are the details of this novel atomic clock experiment and the fact that this experiment can be conducted with currently existing clock technology at comparatively low cost. Okay, so the National Institute of Standards and Technology, otherwise known as NIST, is home to some of the leading experts in both atomic and optics clock technology. The NIST 2010 relativity tests proved time dilation differences between clocks placed a meter apart in height within the gravity potential of Earth, and time dilation effects between clocks moving at relative speeds of less than 30 miles per hour difference. NIST recently reported in Nature on the 17th of February 2022 that they have now measured time dilation differences only 1 millimeter apart in height. Einstein's theory of general relativity predicts that a gravitational field will slow time, and Quantum magazine tweeted their article regarding this recent precision clock result, stating that gravity slows time. However, as an exercise in logic, one could take the viewpoint that these experiments have only proven that clocks tick faster when placed higher up within a gravity potential of a gravitational mass, and have not, strictly speaking, proven that gravity slows time. In order to definitively test if gravity slows time, one would need to place 2 clocks at the same height within the gravity potential, but at locations of differing geological density. This experiment could, as per these Clock on a Mountain cartoons, be conducted by NIST's portable atomic clocks if both of the clock's differing locations were located at the same position on the longitude as well as at the same height. However, in consideration that the sensitivity of current clock technology is now so precise, it can measure time dilation differences at only 1 millimeter distance apart in height, the experiment that I suggest could be conducted in the laboratory. By placing two clocks at the same height so they tick at the same rate, and then by placing a large amount of some very dense material, such as osmium, which packs 22 grams into 1 cubic centimeter, under one of the clocks, a greater gravitational field can then be artificially created for that clock to then be subject to. In this fashion, one can truly test if gravity slows time, in that this experiment is designed to rule out or rule in the possibility of any other variables being at play here. Einstein's general relativity predicts that the clock subject to the greater gravitational field will tick slower. My modification of general relativity predicts that the clock subject to the greater gravitational field will tick faster. The clock that is subject to the greater gravitational field will either tick slower or faster. There is no wiggle room here. Either my modification of general relativity will be falsified, or this particular aspect of Einstein's general relativity will be falsified. Now, to say so, as I outlined in episode 1, via the principle of mass-energy equivalence, and in that frequency and energy are proportional, there are clues existing within the manner by which an atomic clock is calibrated that are suggestive that more energy is required in order to cause a clock to tick faster. Also, there are clues existing within the research of Dr. Natalia Ares and co. that are suggestive that a hotter clock is more accurate, where a clock that is more accurate is operating at a higher frequency of oscillations. Therefore, going back to the principle of mass-energy equivalence, on the basis that the current interpretation of the general relativity mathematics states that a system with more energy will cause a clock to tick slower, the possibility arises that something anomalous to Einstein's general relativity may be occurring here, and on this basis it would be a worthwhile venture to conduct this experiment that I have suggested in order to definitively test the hypothesis. In the quest for gaining a complete physical understanding of the universe, it is important that we undertake to look under every stone, so to speak. Okay, so in episode 6, I said that I would be discussing further details as to my modification of general relativity in relation to how gravity does what gravity does, and giving explanation for why the first and second laws of thermodynamics may need redefining within the structure of my proposed cyclic contracting bounce cosmology. I don't actually have time to get into these subjects today, so I'll have to leave this discussion for a future episode. Meanwhile, I have left links to all of the aspects that I have to discuss today in the video notes. Thanks for watching.